Method to approaching this question is to realise what information have they given you and how can it be represented. So they've given us some information about the bowl here, that they know that it comes in at a constant rate. So that is a volume that comes in a known amount of time. So we know what dV dt is. So that's a volume with time. We have a volume here with in terms of h. That means I can deal with a dV dH. And when we come to the end, they say find the rate and change of the height of the water in centimetres per second when h is 15. So that is a dH dt term. Flashing mics if you think that's okay. Okay, I think everyone got there. So now using this, we just have to identify what we can do to actually create a chain rule. Well, both of these have a dV on the top, so they're either side of the equals. We're looking for something with a dH on the bottom to go with the dH dt. So we have dH and dH dt. And that means we can get the final thing, which is the volume as a rate. Okay? So my next step is I need to know what dV dH is. I know what dV dt is, that's 180. I need to work that one out, and that means I can find the dH dt at a known time. So dV dH, just scroll this down a bit. So the next step is now, just clicked on the edge of the blooming picture. So dV dH, I'm going to take the 1/3 outside of the differential. So it's 1/3 of pi of d dH. You're familiar with that? You can factor out the constants. Flashing microphones if you're okay with factorising out the constant. Cool. Of 90h squared minus h cubed. So when we do the differential, we get 1/3 of pi 180h minus 3h squared. So now what we can put in is both sides of my chain rule. So we know dV dt is 180. And that is equal to this dV dH, 1/3 of pi at 180 times 15, subtract 3 times 15 squared, and that will give me dH dt times dH dt. So now it's a case of calculating with your left, right and centre. I don't have my calculator on screen handy. Actually, I might do it. Might be able to get it up quickly. Apps. Calculator tools. Math tools. Calculator. By the way, can you drop me a note if you use graphic calculators, any of you? Because I can teach with them. I do use for demonstrations. So let's calculate this left-hand side first. So it's 1 shared by 3 multiplied by pi multiplied by the bracket. Let's make it a little bit bigger so we can see what's going on. 180 multiplied by 15, subtract from that 3 times 15 squared, and that side calculates as 2,120. So I'm going to store that in memory. Store there, shift, store, and that one was the rate of volume, wasn't it? So I'll just store it in an A. It's worth storing answers like that because they have a habit of being reused. So if I pull up memory A, I can get my number back. So to get dH dt is 180 divided by what my value in A is. And it gives me 0.8488, which I remember was good. 0.08488 is dH dt, and my solution, they said, to two significant figures. So this is approximately 0.085 units. Well, the volume, the speed was in centimeters, and the volumes were in centimeter cubed. So we've got centimeters per second. Are you okay with that question? Flash your mics. Okay, Tal, thanks. Thanks, Olga. Thank you, Bergjan, Anna. Richard and Thomas, I didn't see you two. You want to talk in a minute, okay? The next part that we've got today, I'll just stop that video.